So here we are going to discuss about the NEET important topics and the past paper questions for the chapter Aldehydes, Ketones and Carboxylic Acids. So some of the chapters we already covered in our previous classes. So today we are having the chapter Aldehydes, Ketones and Carboxylic Acids. This is an important chapter from the organic chemistry, so we can expect more questions from the chapter. Okay. So first we will go through the important topics, then we will go to the past paper questions. So first we have to know what are the important reactions, what are the important properties, and what are the different types of aldehydes, ketones and carboxylic acids. Then we will discuss about their reactions as well. Then we will move to the past paper questions from the chapter. Okay. So let us start from the aldehydes, ketones and carboxylic acids. So all the aldehydes, ketones and carboxylic acids, they are containing the carbonyl group. Carbonyl group means this CO group. So looking to this group, we can see the oxygen is more electronegative. So they are having a partial negative charge and carbon is partially positive. And if you check the aldehyde, they are RCHO and ketones are RCOR, and if you come into the carboxylic acid, it will be RCOOH. Means all of them are having this carbonyl group and this bond is polar. Polar means there is a charge separation in this carbon oxygen or carbonyl group or carbonyl bond. Okay. Now the bond angle present in this carbonyl group will be 120, means this bond angle is 120 degree. That is also important. Now the geometry. The local geometry around the carbonyl group will be trigonal planar because we know that the bond angle is 120 degree, right? So here the geometry around this carbon, we can see from this diagram they are arranging in a trigonal planar manner. So this is trigonal planar. And now here you can see that the local trigonometry planar geometry. See, if you check this one, this carbon atoms and this carbonyl groups, we can see the geometry is trigonal planar. Now we are moving to the aldehydes first. So aldehydes means, as we know, they are RCHO, means the carbonyl group is connected to one alkyl group and one hydrogen. That is called that is called aldehydes, right? So for the aldehydes, general formula we can write it as RCHO. So we can replace the R group with hydrogen or some other cyclic groups like cyclopentane group or anything, or normal alkyl groups are also fine like CH3, CH3, CH2, ethyl group, propyl group, methyl groups are also fine. So when we replace the R group with different atoms or with different groups, we will get different, like if we are replacing with hydrogen, we will get formaldehyde. If it is CH3, we will get acetaldehyde. Like we will get different kind of compounds. That is the thing regarding this aldehydes. Now coming to the ketones. Ketones means the carbonyl group is connected to two alkyl groups. They can be represented by the letter R and R dash. So one side of the carbonyl group will be R and the other side will be R dash. So they are called ketones. And here the R and sometimes the R and R dash may be same, sometimes they are different. Okay, so in the first example, we can see one side is CH3 and other side is CH2, CH3. And in the second one side is CH3, other side is a cyclic ring. Like that means it may be different or same. One may be aliphatic, other one may be cyclic. Like that also possible. Okay, so in all these three, we can see the carbonyl group, that is CO group. Now the next one is carboxylic acids. As we all know, the carboxylic acid is also containing the carbonyl group, and one side we can see the R group as similar to that of aldehydes and ketones, and the other side instead of the hydrogen or the alkyl group we are having a hydroxyl group. so that they are called carboxylic acids. So in carboxylic acids, one side of the carbonyl group is having the alkyl group and other side is having the hydroxyl group. Now coming to this alkyl group, this may be simple alkyl groups or cyclic groups or hydrogen, whatever. It is possible for any, like the R group may be cyclic ring or alkyl group or hydrogen. All are possible. Okay, and this alkyl group may be primary, secondary, tertiary, whatever it is, it will be carboxylic acids. So this is the functional group in carboxylic acids, including carbonyl group. Now we will move to the esters. Esters means they are produced when acids react with alcohols. When acids react with alcohols, we are getting the esters. So they are usually produced by the removal of water molecule, because if I am taking an alcohol that is ROH react with an acid that is RCOOH, I can see that the water molecule will be removed, means the hydroxyl group from alcohol or hydrogen from acid, or opposite is possible, like hydrogen from the alcohol and hydroxyl group from acid is also possible. When they remove, they will produce ROCOR. So this is the ester. So the COO bond is the ester linkage present in this ester. So in this ester also we can see there is the carbonyl group, and here the carbonyl group is connected to one side, it is connected to the alkyl group, other side it is connected to the alkoxy group. That is the difference. So here also we can see that CO group is there along with one oxygen. Now, another kind of compounds containing the carbonyl group will be the amides. So the amides means they are the first nitrogen containing organic compounds. So in case of amides, we can write the amide bond, that is RNCO-NH bond. This is the amide linkage or amide bond. So if you take the first compound, we can see that there is an amide linkage, means the carbonyl group is connected to the nitrogen, and there is an R group on the carbon, and there are some other two groups on the nitrogen. So usually it will be CON linkage or CONH linkage, and the compounds containing these amides are usually different kind of compounds are there, diamides are there. Okay, so these are called amides, and the general formula is this thing. So here in all these compounds we can say there is CON linkage, means the hydrogen may be replaced by the alkyl group, or maybe hydrogen may be present in sometimes. That doesn't matter. Anyway, it will be CON bond. Now we are going to the oxidation. When the alcohols, when a primary alcohol, do you know what are primary alcohols, right? Primary alcohols means the hydroxyl group connected carbon or hydroxyl group containing carbon will be connected to only one carbon atom, means only one alkyl group. They are called primary alcohols. So when the primary alcohols are undergoing oxidation, they will produce the aldehydes. Okay. While at the same time, when a secondary alcohol is undergoing oxidation, they will produce a ketone. That is the difference between a primary alcohol and the secondary alcohol. Means primary alcohol can produce aldehyde and secondary alcohols are producing ketones by oxidation reaction. So oxidation means it is the addition of oxygen or removal of hydrogen. So here we can see the hydrogens are removed, and here also the hydrogens are removed to produce the carbonyl group. Now coming to the cyclic structures. Cyclic aldehydes are not possible because always the aldehydes means it is RCHO group, means one side of the carbonyl group will be hydrogen at all time. So this is always possible at the end of the chain. So within the cyclic ring, within the ring, the aldehyde group cannot be possible. So usually cyclic ketones are possible, means the keto group can be introduced as a part of the cyclic ring, but the aldehyde group cannot be introduced as a part of the cyclic ring. But aldehyde group can be introduced by replacing the hydrogen atom from the cyclic ring. But within the cyclic ring we cannot introduce an aldehyde group, but within the cyclic ring we can introduce ketone. See, in the first example, cyclic ketone, here we can see that there is a CO group. This is due to the presence of this CO group within the same ring itself. This is not a branch or anything. This CO group is a part of the ring itself. So they are cyclic ketone. Now, if you are moving to the cyclic diketone, it will be like two CO groups will be there. They are cyclic diketones, right? Now, if you come into the aldehyde, you can see that the CHO group is not in the ring. They are outside the ring, means they are part of the ring, but they are not coming inside the ring. So this is the difference between cyclic aldehydes and cyclic ketones. So aldehydes cannot cooperate in the ring structure and it is not a part of the ring. And coming to the ketones, we can see the ketones are not heterocyclic compounds. Means there is no any oxygen or nitrogen or sulfur atom within the ring. Still the oxygen atom is moving out towards the ring, like it is not within the ring. It is not inside the ring. So they are not heterocyclic compounds. Now we know the nomenclature of aldehydes. So the nomenclature of aldehydes includes usually the suffix al, means the E from the alkane or alkene or whatever the hydrocarbon. If it is alkane, we can remove the E from alkane and we will add the suffix al. So we will get the name of the aldehyde. So suppose the aldehyde is always the CHO group is always coming at the end of the chain, and if the aldehyde is containing three carbon atoms, usually the hydrocarbon containing three carbon atoms will be propane. Propane, propane. So if there is a aldehyde group in the chain containing three carbon, so the three carbon means they are including the aldehyde carbon as well. So that is CH3, CH2, CH3 is the propane. And if you come to aldehyde, it will be CH3, CH2, CHO. Means the third group itself is the aldehyde group. So we are including that carbon as well for naming. So it will be the E will be removed and we will add al. So it is propanal. So the name of the aldehyde will end with al, Al. Okay, so whatever the number of carbon atoms, we will use met et prop but based on the number, means whatever the number of carbon, we will use the root words. So here we can see another example, see formaldehyde. Formaldehyde means it is having only one carbon, that is methanol. So they are connected to both the hydrogens are there. So coming to the acetaldehyde means there are two carbon atoms, so they are called ethanol. And if the compound is containing three carbon atoms, there will be propanol, means the three carbon chain is propane. And if you come into the four carbon chain and the last carbon atom is the CHO group, it is called butanol. So this is how we are naming the aldehydes. Now, if you come into the aromatic aldehyde, as we discussed before, the aldehyde group is not the part of the ring, but they can come outside the ring, means they will be coming by substituting the hydrogens from the benzene ring. So usually they are called benzaldehyde and the structure is also given here. So if you are replacing any one of the hydrogen from the benzene ring with some other atoms also, we will get the derivatives of the benzaldehyde, like 4-bromobenzaldehyde, 4-hydroxy, 2-methyl benzaldehyde, means the derivatives of the aldehyde containing some other functional groups will be possible. Next, if you come to the nomenclature of the ketones means the name, like aldehydes, the name was ending with Al, right? But in case of ketones, the name will end with One, on. Okay, if it is a three carbon, it will be propanol, means we will remove, anyway this group will comes in between, so it will be CH3, COCH3. So usually the name will be propane. Now I am removing this E and adding ONA. So the name will be propanol. This is the name of the ketone containing three carbon atoms. So this is how we are naming, means we will remove the E and we will add the suffix ONE. Okay. There are some examples as well, that is ethyl propyl ketones, isobutyl methyl ketones, 1-bromo-ethyl methyl ketones. Means based on the substituents we have to name in different way. Now the type of isomerism among aldehydes and ketones. Actually, the aldehydes and ketones means both of them are containing the same functional group, but carbonyl groups are present. But in aldehydes, one side of the carbonyl group will be hydrogen, other one will be the alkyl group. But in case of ketones, both the side of the carbonyl group will be entered with the alkyl groups only. So if you check the aldehydes and ketones containing same number of carbon atoms, they will be isomers. What are isomers? Isomers means the compounds, they are having same molecular formula but different structural formula. So if you consider the aldehydes and ketones, they are having the similar molecular formula, but the functional groups are different, because in aldehyde it is aldehyde group, in ketones it is the keto group. So if you consider these two, this is propanone and this is propanol. So first let us check the molecular formula of these two compounds. The first one is 3 carbon, so C3, and number of hydrogen is 6, number of oxygen is 1, so it is C3H6O. Now coming to the second one, here also we can see 3 carbon atoms and 6 hydrogen atom, 1 oxygen atom. So both of them are having same molecular formula, that is C3H6O. And if you check the structure, we can see the first one is an aldehyde ketone and the second one is an aldehyde. Means their functional groups are entirely different, right? So these kind of compounds are called functional isomers. So we can say that the aldehydes and ketones, both of them are functional isomers. They will show the functional isomerism. So this is the type of isomerism existing in aldehydes and ketones. Now, among the ketones, we have one more type of isomerism, that is the positional isomerism. The positional isomerism usually arising due to the presence of the functional group at the different positions in the chain. We know that if you have 2-chloropentane, we can write 3-chloropentane as well. Means just we are changing the position of the chlorine in the chain, and we will get 2-chloropentane and 3-chloropentane. But if you take the aldehyde, as I told you before, the aldehyde groups can come at the end chain. It means at the end of the chain at all the time. But if the group is the keto group can be come in between. That is the thing, right? So the keto groups are usually coming in between the chain. So if you take one example, I'll take a 5 carbon chain, and the second carbon I am writing CO, and other atoms are CH2, CH2, CH3. So here we can see this is pentanone, because this is containing keto group, but this is a pent 2 on, means the second carbon is the carbonyl group. So it is 2-pentanone. Now what I can do is I can place the carbonyl group in the third position. So this carbonyl group itself is a part of the chain because it is contained in the carbon atom. So I am writing here, that is the CO group is present in the third position. So here what I am getting here is 3-pentanone. 3-pentanone means the CO group is present at the third position. So these two are positional isomers, because if you check the molecular formula, both of them will be C5 C5H10O, and the second one is also C5H10O. But both of them are having same molecular formula, same functional group also. They are different compounds. One is 2-pentanone, other one is 3-pentanone, because they are changed they are differed by the position of the functional group, that is the keto group. So this is the another type of isomerism that we can see in case of ketones. But this is not possible in aldehydes, because for aldehydes, the aldehyde group is always coming at the end of the chain, not in between. That is the thing. Now we have to know some common aldehydes and ketones that we are using in our daily life for experimental purpose and everything. So the first one is vanillin. This vanillin means we are using this vanillin for vanilla flavoring in food. Food industry, we are using vanillin for giving the a flavor of vanilla. Okay, that is the one compound. So here, please try to remember the structures of these kind of compounds. Second one is benzaldehyde. Benzaldehyde is usually using in perfumes industries and everything for providing a smell of almond. Almond flavoring is done by using the benzaldehyde. So this is also important. Next is cinnamaldehyde. Cinnamaldehyde is also another type of aldehyde, and they are using to provide the cinnamon flavoring. So these are mainly used for industries like perfume industries, then the food industries and everything for providing these sweet smells. Okay, so these are the common type of aldehydes that we are using, and for them we have to remember the structures. That is very important. Next is the some ketones that we are using in our daily life. The first one is 2-heptanone, that is used for giving the flavor of the cloves. So clove flavoring is given by 2-heptanone, and the next one is butadiene, that is butadiene is providing the butter flavoring. That is also important, and here we can see the structure as well. They are containing two carbonyl groups. That's why they are called dione. Now the third one is Carvon. They are also providing the mint flavor of the mint. So mint flavoring is given by the compound Carvon. So these three are the compounds containing keto group, means they are ketones. The previous one they are aldehydes. That is the difference. Now we are moving to the physical properties of aldehydes and ketones. Usually, neither aldehydes nor ketones possess the ability to produce hydrogen bond with other molecules like themselves. So, as a result, the boiling point of a substance is completely depending on the intermolecular interactions, right? So, if you check the aldehydes and ketones, they are not producing the hydrogen bond. It means the boiling points of aldehydes and ketones will be lower than for alcohols of similar molar mass, because alcohols are able to produce the hydrogen bond. Alcohols can, between the alcohol molecules, there is a possibility for the formation of hydrogen bonding, that is intermolecular hydrogen bonding. While you are coming to ketones or aldehydes, there is no any possibility for the intermolecular hydrogen bonding. It means they are not having that much higher boiling point like alcohols. That is another thing. Now here the carbon oxygen double bond in the aldehydes and ketones, in these molecules is polar, because oxygen is more electronegative, so they will get a partial negative charge. Carbon is less electronegative, so they have a partial positive charge. So between this ketone molecules, between the ketone molecules, we cannot see the hydrogen bond that I told you, because there is no free hydrogen atoms. But between the ketone molecules, there is an chances of dipole-dipole interaction. Because if you have another ketone, we can draw the ketone molecule like this only, right? So there will be so we can draw the structure, that is C double bond O. So the oxygen atom having a negative charge and carbon is having a positive charge. So the oxygen atom having a negative charge of one carbonyl group can, one ketone or aldehyde can interact with the carbon atom of the next molecule, because they are oppositely charged. So we can say this is not hydrogen bonding, because hydrogen atoms are not interacting here. Here actually this CO group is one dipole and other one is another dipole. So this interaction is usually called dipole-dipole interaction, because the carbonyl groups are behaving as dipoles. So the boiling due to the dipole-dipole, so among the intermolecular forces, the hydrogen bonding will be stronger. Then the next one will be dipole-dipole interaction. So the dipole-dipole, due to the presence of this dipole-dipole forces, they are also having the strong interaction. It means they have higher boiling point than normal alkanes, means normal hydrocarbons. If you compare the boiling point of these ketones with normal hydrocarbons, this boiling point of them will be comparatively higher because of the strong intermolecular forces. That is another, means this intermolecular force is not hydrogen bonding, this is dipole-dipole interaction. Now, here the molecular masses of some aldehydes and their boiling points are given. These are important because we have to know how to compare the boiling point if the points, if still even they are having similar molecular masses. For the this ethane, methanol, methanol, they are having molecular mass which are similar. That is 30, 31, 32. But if you check the boiling points, we can see the methanol is having higher value, 65. This is because of the presence of the intermolecular hydrogen bonding. And in case of ethane, there is only van der Waals interaction or the London forces or dipole dispersion forces only. It means there is that interaction is not that much stronger. So they are having very low boiling point. But if you come to the usual aldehyde, means a formaldehyde, there is a dipole-dipole interaction. Due to this dipole-dipole interaction, they are having higher boiling point than that of ethane and lower value than that of alcohol. And here also we can see the other example. So this is the reason for the difference in their physical properties. Another physical property is the formation of the hydrogen bonding that we discussed now. That is the water molecules are usually, means we can explain the solubility. So solubility of aldehydes are key and ketones in water can be explained by using the concept of the same hydrogen bonding. Means between the water molecules there is a hydrogen bond. Means the hydrogen atom of one water molecule can interact with the oxygen atom of the other one. So there is a kind of intermolecular hydrogen bonding in aldehydes in water. So when the ketones are dissolving in water, when the aldehydes are dissolving in water, they can produce hydrogen bonding. Between the aldehydes or between the ketones, there is no hydrogen bonding because free hydrogens are not there on oxygen. But if you take water and an aldehyde, or if you take a water and a keton, there is a possibility for the hydrogen bonding because the hydrogen atom of the water can interact with the oxygen atom of the keton or aldehyde. So between water and this carbonyl compounds, there is a possibility for intermolecular hydrogen bonding. It means they are usually soluble in water. That is the another solubility factor and a solubility thing regarding the aldehydes and ketones. So in the first diagram, we can see the hydrogen bonding between aldehyde and water. And in the second diagram, we can see the hydrogen bonding between ketone and water. So these are the type of hydrogen bondings present in aldehydes and ketone molecules. And here we can see the data regarding the solubilities as well. And here, if you check the solubility, the methanol will be very soluble because when the length of the hydrocarbon chain in aldehyde or ketone increases, they become less soluble. Because when the length of the hydrocarbon part in the aldehyde ketone increases, it means there will be more interaction, means there will be less interaction, means that they are hydrophobic ends, right? So these hydrophobic ends are making them less soluble. That's why when the chain length is increasing, when the hydrocarbon part is increasing, they are becoming less soluble in water. Next one is we are moving to the preparation of aldehydes and ketones. So we already discussed about the preparation from primary and secondary alcohols. Primary alcohols on oxidation, they are producing the aldehydes and the secondary alcohols are producing ketones. So here also we are using the oxidizing agents such as potassium permanganate or potassium dichromate. And in case of ketones, they are not undergoing oxidation, so they are not producing any products. But aldehydes, which is producing from the primary alcohols, they can undergo further oxidation and they will produce carboxylic acids. But if you come to the secondary one, secondary will produce directly the ketones. Secondary alcohols can produce the ketones and these ketones cannot undergo further oxidation. So ketones are resistant to oxidation. That is also important. Now we have several tests to determine the presence of aldehydes and ketones. The first one is the tolerance test and the second one is the Benedict's test. So these are usually using to distinguish between the aldehydes and ketones. So this is also important here, and both aldehydes and ketones can be easily reduced to alcohols with hydrogen using a catalyst. So that reaction is also given here, that is the alcohols can be converted into carbonyl compounds. Now, if you check the reactions of aldehydes and ketones, when aldehyde or ketones react with an alcohol, they will produce hemiacetal. So when these hemiacetals are reacting with alcohol again, they will produce the acetals. That is another kind of reaction. Now here we can see the reactions of the aldehydes and ketones. It is shown here, the hemiacetal formation from aldehydes and ketones. So in this hemiacetal, we can see that it is an organic compound that is containing a carbon atom that is bonded to the hydroxyl group. And here we can see hydroxyl group is there, and also the oxygen atom is also there. That's why they are called acetals and hemiacetals. Okay. Now, when these hemiacetals are again react with alcohol, they are converting into acetals. That is also important. So first we will convert the aldehyde and ketone into a hemiacetals by reactions with alcohols, and the hemiacetals produced again react with alcohol and they will produce the acetal. So these are the reactions. Now we have the sulfur containing carbonyl compounds. The sulfur containing carbonyl compounds are usually thioaldehydes and thioketones. Thioaldehydes means instead of here oxygen we have sulfur, and in thioketone instead of the carbonyl group the oxygen we have so the CO group will be replaced by CS group, that is thioaldehydes and thioketones. So, second case is sulfoxide. Sulfoxide means the carbon atom from the ketone will be replaced by sulfur. That is called sulfoxide. Okay, then we have the compounds such as DMSO, and that is dimethyl sulfoxide or acetone. They are some examples, and they are used for the solvents in many reactions as well. So these are the things regarding the aldehydes and ketones. These are the reactions, preparations of aldehydes and ketones. Now we have to go through the important questions from the chapter aldehydes and ketones, that is the past paper questions. So coming to the first question, that is here it is given that failing solution A. We have to identify what is failing solution A. Actually, the failing solution is usually using to test for the presence of reducing sugars. And they are usually the failing solutions can be prepared by mixing failing solution A and failing solution B, failing A and failing B. So failing A will be the copper sulfate solution. Failing A is copper sulfate, and they are providing the Cu2 plus ions. While coming to failing B, they are sodium potassium tartrate. Sodium potassium tartrate. The sodium potassium tartrate is called filling B solution, and there is a mixture will be there, means a strong alkali will be added which helps to keep the Cu2 plus ions in the solution. So filling A is copper sulfate, filling B is sodium potassium tartrate, and they are when the filling solution is heated with reducing sugars such as glucose, or the Cu2 plus ions can be reduced to Cu2O and they will produce the brick red precipitate. That is the reaction with filling solution. So here we have to identify the correct answer. So from these options we can see the first one is sodium potassium tartrate or Rochelle salt. That is not filling A, that is filling B. So this is incorrect. And the second option is aqueous sodium citrate. That is also wrong. So the third one is the correct answer. That is filling solution A is aqueous copper sulfate solution, and they are providing the Cu2 plus ions. And option D is also wrong. That is alkaline copper sulfate. So the correct answer is B. Next question. We have some reagents here. We have to identify the reagents that do not react with glucose for the corresponding test. So the reagents with which glucose does not react to give the corresponding test or products we have to find out. So we have different reagents here: toluenes, Schiffs, HCN, NH2OH, NaHSO3. So first let us see what are different reagents given here. First one is toluenes reagent. The toluenes reagent means they are used to test for aldehydes. Tolerance reagent is used to test for aldehydes. Okay, and they are using to distinguish the aldehydes from the ketones, and it is an ammoniacal silver nitrate solution. Ammoniacal AgNO3, ammoniacal silver nitrate solution. That is called tolerance reagent. Now, the second one is shift reagent. Before that, if you use the tolerance reagent, the aldehydes will produce the positive test. Means the tolerance test is providing a silver mirror, a shiny silver mirror on the test tube, in the inner face of the test tube. So aldehydes will give the test. That means they will produce the silver mirror, while ketones will not produce the silver mirror. So that's how we are distinguishing the aldehydes and ketones by using tolerance reagent. The second one is the Schiff's reagent. Schiff's reagents are usually using to detect aldehydes, and it is a sulfuric acid solution actually, and they are colorless, but it will turns to pink or magenta when it react with aldehydes. So that is also used for the detection of aldehydes. Now coming to HCN, NH2OH, NaHSO3. So among these three, the Schiff's reagent and this NaHSO3, both Schiff's reagent and NaHSO3, both of them are not reacting with glucose. All others are usually reacting. So here from the options we can see we have to choose the correct option which is not reacting. So B and E. B and E means option A is the correct answer. In the next question, we have a reagent and the means a cyclic compound is there and the reagents are given as potassium permanganate in presence of acidic medium. We have to find out the major product obtaining in this reaction. So this reactant is an alkene containing the cyclic rings and they are converting into this product in presence of KMnO4. So first let us complete the reaction. So first I am writing the reagent. This is the reagent that we are using here. And this reagent is reacting with KMnO4 in presence of H plus ions. So the product obtained will be the compound containing the COOH group or the carboxylic group. Means the whole compound, the whole group will be changed to the carboxylic group. So here we can see the correct answer is option D. That is the the compound is cyclohexanoic acid. In this question, we have some reactions, chemical reactions, and the products are also given. We have to find out the incorrect reaction from the option. Okay, so let us analyze the each react. Let us analyze each of the reactions given here. In the first reaction, we can see the acyl chlorides are heating with water and they are converting into carboxylic acids. This is possible because when the acyl chlorides are undergoing heating, they will always convert into the corresponding carboxylic acids. Now coming to the second one, here it is given that the amide which is on reduction with lithium aluminum hydride in water, they are converting into acid. This reaction is not possible because when this amide is reacting, that is CONH2, amide is reacting with lithium aluminum hydride, which is a strong reducing agent. Here the group, this amide group will be converting into CH2NH2 group. That is, they will produce this CO group will convert into CH2 and the NH2 group is still there. So this is the product obtaining here, not the carboxylic acid. So here the incorrect option is incorrect conversion is option B because here the products are converting the CONH2 group, that is CONH2 group is converting into CH2NH2 group. So option B is the incorrect one. If you check other options, they are correct because in third one we can see the alcohol is converting into carboxylic acid by the oxidation. So this oxidation means it is possible because alcohols on oxidations they are converting into carboxylic acids. This is a primary alcohol as well. So this reaction is fine. And the last one is again the primary alcohols on oxidation with CrO3, H2SO4, they are converting on reaction with CrO3 and H2SO4 converting into acid. This is also possible. So the incorrect option is B. The next question, we have another incomplete reaction. We have to identify the major product A for the reaction. And the reaction is given as, this is a ketone containing two carbonyl groups, and they are reacting with zinc amalgam and concentrated HCl. So the products are A and water. So we have to identify A in the reaction. So this reaction is Clemenson's reduction, because zinc amalgam and HCl, they are the reagents for Clemenson's reduction reaction. So the given reaction is Clemenson's reduction. So in Clemenson's reduction, usually the carbonyl groups will be converting into CH2 groups. That is the reaction. The carbonyl group can convert into CH2 group. So here we can consider the reaction, that is the ketone, that I will draw the structure of the ketone given here, which is having the ring structures. Actually, the ring structures will be unaffected during the reaction. Only the keto group will be converting into the CH2 group. So this is the reactant, and the reaction is in presence of zinc amalgam and HCl. So here the CO groups will be converting into CH2 groups. So here we can see the product will be, this is the product, means all the CO groups, means two CO groups were there, both the CO groups are converted to CH2 groups, so that we are getting the given product. So this kind of reduction reactions are called Clemenson's reduction reaction. So this is the conversion of the keto group into the hydrocarbon, that is CO group to CH2 group. So this is the answer. So now let us see the options. In the first option, we can see that there is CH2 groups are less here. Means the CO group is containing carbon is entirely missing. That is wrong. And coming to the second option, this is the correct answer according to our equation. So option B is correct. Why the option C and D are incorrect? Because in option C, the CO group is converted to hydroxyl group. That is also wrong. And in B, we can see there is again the conversion of the group into CH2OH. Means the terminal carbon is converting into CH2OH. This is not at all possible here. So here the correct answer is option B. In the next question, we have to complete the reaction. So here we have to identify the product C in the reaction. So the reactant is a ketone and it is a cyclic ketone. When the cyclic ketone is reacting with HCN, they are producing some intermediate B, and this B on heating with concentrated sulfuric acid, they are converting into C. So we have to identify what is C in this reaction. So here we can start from the reagent here. We are starting from the reactant molecule. That is, before that, let's move to the reaction here. The first one, the first one is the ketone. So we can start from ketone. Here, the benzene ring that is connected to two benzene rings are connected together. And here, the reactant is taken, that is ketone. So we can see that the product obtained here will be, it is a carboxylic acid. So here the correct answer is A. In this question also we have to identify the major product of the given reaction. So here the reaction is given as, this is a ketone reacting with AgNH3 twice plus 3 OH minus. So from the reagent itself it is clear that it is ammoniacal silver nitrate solution. Ammoniacal silver nitrate solution. So here the reagent is a ketone as well. So when ketone react with ammoniacal silver nitrate solution, so this ammoniacal silver nitrate solution is called Tollens reagent. Tollens reagent. So this ammoniacal silver nitrate, when react with the Tollens reagent, we know that they will produce the precipitate of silver because this is a ketone. So here the product obtained will be, we can write the overall reaction, that is the aldehyde. that is the ketone, react here. Before that, we have to write the structure of the ketone that is given here, and the reagent is 2 moles of AgNH3 twice plus silver nitrate, ammoniacal silver nitrate solution complex in presence of OH minus. They will produce the product that is the benzene ring. It's connected to CO. This is the ring and O minus. So this will be the product obtaining here. So from these options, we can see this product is option D. So this will be the correct answer. In the next question, we have to identify the final product obtained in the given reaction. So the reaction is, we can see that the ethanol or acetaldehyde react with lithium aluminum hydride in presence of acidic medium, and they are producing some intermediate A, and this intermediate react with sulfuric acid and they are converting into another product B. This is the reaction, and this B on reaction with hydrogen bromide, they will convert to C, and the C on reaction with the bromobenzene in sodium or dry ether medium, they will produce the product D. So this is the overall reaction. Now we have to find out the final product D in this reaction. So we are starting from the reagent, that is the acetaldehyde. So CH3CO H react with lithium aluminum hydride in presence of H3O plus. So this is the reaction. First step, they will convert into the corresponding alcohol because the reducing agent is here. So the reduction reaction will take place and they will convert to CH3 CH2OH, that is the alcohol. And the second, so A is alcohol, that is ethanol. Now A is reacting with sulfuric acid and followed by heating, they are converting into another product, right? So with heating with sulfuric acid, they are converting into, means they will undergo dehydration reaction. The dehydration means they will undergo removal of water molecules. So they will convert into CH2 double bond CH2. So this is the alkene producing in the second step. So B is ethene. So A is an alcohol, that is ethanol, and this alcohol on reaction with sulfuric acid, dehydration takes place, that is the removal of water molecule takes place, and they will convert into ethene, that is B. Now this ethene react with hydrogen bromide and converting into C. So here the ethene, when an alkene react with hydrogen halide, the reaction will be addition reaction, right? So one hydrogen move to one carbon, bromine move to other carbon. So the product will be CH2Br CH3, means a bromoethane will be produced. That is the product C in the reaction. Now this bromoethane is reacting with bromobenzene. So when bromoethane and bromobenzene reacts together, you are getting some other product because this reaction is Woods-Fittig reaction. So as a result of the Woods-Fittig reaction, you will get the product which contains both the hydrocarbon part combines together. Means the benzene ring in this bromobenzene and the ethyl part in the bromoethane will combines together and they will produce CH2, CH3 here. So ethyl benzene will be produced. So this is the reaction, final product obtaining here. So D is the product, that is ethyl benzene is the final product. Now let us see the option. The first option is again incorrect because this is not ethyl benzene because there is no benzene ring as well. Coming to the option B, that is the ethyl benzene, means this is the correct answer. Coming to option C is wrong because here we can see two benzene rings, that is not at all possible. And option D is C4H10, that is butane, that is also not possible. So the correct answer is option B, that is ethyl benzene. And this reaction we can say Woods reaction because in Woods reaction usually the one aldehyde when one alkyl halide react with other alkyl halide in presence of sodium, because here the catalyst is given as sodium metal. So when one alkyl halide react with other alkyl halide in presence of sodium metal, they are producing the corresponding product, right? So this is the reaction, and here we can see that the hydrocarbon parts are combining together to produce the final product. So this is Wood-Spittig reaction. In the next question, we have two statements and we have to find out the... In the next question, an incomplete reaction is given, that is RMGX, that is the Grignard reagent, react with carbon dioxide in dry ether medium and they are producing the compound Y. And this Y on hydrolysis is producing the compound, the final product, that is the acid. We have to find out the Y which is forming in between the reaction. Okay. So first we have to write the overall reaction, that is RMgX react with CO2. So CO2 is like this. This carbon is bonded to two oxygens, that is double bonds. And we have the RMgX, that is the Grignard reagent as well. And the first step is in Grignard reagent, R group is minus and this magnesium is positively charged. So on the first step, this R group is attacking the carbon and this double bond is moving to oxygen. That is the reaction with the Grignard reagent, right? So the product will be RCO MgX will be produced, means the R group will be bonded to the carbon dioxide. So you will get RCOO will be produced. The first step is carbon dioxide react with RMgX. This is negative, this is positive. And here the negative charge is attacking the carbon. And this is moving to oxygen. So you are getting the product, that is RCOOMgX, means this oxygen is having the negative charge due to the jumping of the electrons, right? So that oxygen gets bonded to the MgX part and this carbon will be connected to the R minus. So this one. Now this is the compound Y producing here. Okay, now when this Y is reacting with water, means when they are undergoing this acid hydrolysis, that is in presence of H3O plus, they are producing the compound, that is RCOOH, and they will produce the side product, that is MgOH. Means during the hydrolysis the bond breaking is taking place here and the hydrogen will go here, OH will go here, because water is containing H plus and OH minus, right? So the H plus ions will go with the RCOO part and OH will go with the MgX part. So you will get the acid as the final product. Now let us see that why is this intermediate. So let us identify the Y in these options. The first one is R3COO minus. This is not at all possible. Option B is not containing magnesium. That is also wrong. Option C is containing 2 RCOO group and magnesium. That is also wrong. And option D is the correct answer. That is RCOO minus MgX is the intermediate in this reaction. So option D is correct answer. Next question. Here we have different products. We have to identify the one which is not formed when acetone react with 2-pentanone in presence of dilute sodium hydroxide followed by heating. So we have to identify the product which cannot be produced by the reaction. So here we have to consider the reaction first. When the acetone is undergoing nucleophilic addition reaction in presence of Grignard reagent, the product will contain 4 carbon atom with hydroxyl group as the main functional group. So here acetone is having 2 carbon atoms, that is so acetone is having 3 carbon atom, that is CH3COCH3, and this is reacting with 2-pentanone. So first let us consider the reaction. So acetone react with Grignard reagent, that is RMgX, and we are considering the RMgX, that is C2H5 MgBr. This is the Grignard reagent, and the reaction takes place in dry ether medium as well. So here the R group is having the negative charge, magnesium is positive charge. So here what happened here is this C2H5 is attacking the carbon, and automatically this double bonds will move towards the oxygen atom, and oxygen will get a partial negative charge. So here we will get an intermediate, that is CH3 CO. Here the negative charge will be there, so they will be connected to the MgBr part, and the CH3 will be there on the carbon, and the C2H5, that is the ethyl group, gets connected to the same carbon atom. So this is the intermediate that we are getting here. Now this intermediate is undergoing hydrolysis in presence of acidic media, that is acid hydrolysis. They will produce the corresponding product that will be an alcohol. So here we can write the product, that is CH3 CC2H5 OH CH3. So this is the product that we are getting here. So if you check the options, we can see that we have to identify the product which is not formed when acetone reacts with 2-pentanone in presence of dilute sodium hydroxide, right? So here the correct answer is this. This is the product forming here. So this is the correct answer. In the next question, we have to find out the IUPAC name of the organic compound which is producing in the given reaction. Here we have the reactant, that is acetone, and they are reacting with the Grignard reagent in dry ether medium followed by hydrolysis. So we can start the reaction first, that is CH3COCH3. This is acetone, right? So when acetone react with Grignard reagent, that is RMgX is the Grignard reagent. But here the proper Grignard reagent is given, that is C2H5, means the R group can be substituted by C2H5. So it will be C2H5 MgBr in dry ether medium. So here the reaction will be, the first one, the alkyl group will attack the carbon containing the carbonyl group, means the carbonyl carbon. So the double bond will move to the oxygen atom. So here you are getting CH3C. Here the oxygen will carry the negative charge C2H5, then CH3. Now the C2H5 part is attacking the carbon. So in the Grignard reagent, the C2H5 is negatively charged and the magnesium is positively charged. So we can separate the compound into two, which is having the negative and positive charges. So from this compound, now this MgBr will bind with this oxygen. So we can write OMgBr because this is positive, this is negative. Now we have to do the hydrolysis, because after getting this intermediate or this adduct, we have to do the hydrolysis, acid hydrolysis. So during the hydrolysis, the bond breaking will take place between the oxygen and magnesium, that we can show by using the given equation, that is OMgBr. Now the hydrolysis takes place here. So water molecule is containing two parts, that is H plus and OH minus. The H plus ions will move to the negatively charged oxygen, and the OH minus ions will move with the positively charged MgBr part. So the product you are getting here will be CH3C. C2H5 means we can write it as CH2CH3. Now we have CH3. And here the oxygen will be having the hydroxyl, that is hydroxyl group is also there. So this is what we are getting, and the other product will be MgBrOH. So let us name this is the final product of the reaction. Now let us name the compound. In order to name the compound, we can take CH3, CH2, COH, CH3. So this is an alcohol, and the carbon containing the alcoholic group is also containing methyl group as well. So we can name this compound, that is the carbon containing the hydroxyl group will have the less number while naming. They are having the priority. So the compound is 2-methyl butane 2-ol. This is the product that you are getting, 2-methyl butane 2-ol. So from these options, we can see that the correct option is option A, 2-methyl butane 2-ol is the final product of the given reaction. In this reaction, we have to find out the final product obtained. So here the reaction is given as the reagent is having keto groups and there is an ester linkage as well. So we have to find out the product obtained when this reagent is reacting with sodium boron hydride in presence of ethanol. So first let us consider the reaction, that is the benzene ring is containing double bonded oxygen, that is keto group, and CH2COOCH3, and this is also CH3 group, right? So when they are reacting with NaBH4 in presence of C2H5OH, here we can see that they are producing the product, that is the keto group will be converting to OH group, that is the oxidation, that is the reduction, because here the sodium boron hydride is using here, which is a strong reducing agent. So the reaction will be the reduction reaction. So this keto group will be converting into the hydroxyl group and the remaining will be CH2COOCH3, and the methyl group is also still there. So this is the product that we are getting here. Now let us check the options. From the options we can see the same product is in option A, because option C and D we can ignore because here the hydroxyl group is not there, in C because the keto group is there. It is not possible. And in the fourth one we can see the hydroxyl group is present on the chain. That is also impossible. So the correct answer is A. In case of B also we cannot see any change in the reaction. So this is also incorrect. So the correct answer is option A, that is the hydroxyl group. The keto group will be reduced to the hydroxyl group in presence of the strong reducing agent sodium boron hydride. In this question, the reaction is given, that is sodium salt of propanoic acid is reacting with sodium hydroxide and some other reagent followed by heating. They are producing ethane and sodium carbonate. We have to identify the missing reagent in the reaction. So here the reaction is taking place between the sodium salt of carboxylic acid and sodium hydroxide, right? So this reaction is usually taking place in presence of two reagents, that is sodium hydroxide and calcium oxide. So in presence of the sodium oxide and calcium oxide followed by heating, the reactant can convert into the hydrocarbon, that is CH3CH3, which is containing one carbon less than that of the reactant. In sodium salt of propanoic acid, we have 3 carbon atoms, but in the product we are having only 2 carbon atoms, that is CH3CH3, and one carbon atom is going along with sodium carbonate. So the product is having one carbon less, means the reagent should be sodium hydroxide and calcium oxide. So the correct answer for this question is option B. So these are the important questions from the chapter Aldehydes, Ketones and Carboxylic Acids. So we have covered many of the questions from 2024 to 2016. So these are the important areas where we can expect the questions for your NEET exams as well. So prepare well for your exams, because in this organic chemistry we have many chemical reactions. So we will be confused about the reagents, the product reaction conditions as well. So we have to, because if any one of the reagent is changing, it will change the entire reaction, means the product will change. Some aryl compounds will become aliphatic will become aryl. So each reagents are important for a particular reaction. So in organic chemistry, we have 4 different chapters as well, not only 1 or 2. So all these chapters are having many name reactions, many conversions, preparations, properties and everything. So each reactions are important, including the reagents, not only the reactants and products, because many questions we have seen that the products are given, we have to find out the reagents. In some other sequence reactions, the between the reagents might be missing. So we have to identify that products as well. So the not only the matched product, the intermediate products are also important. Okay. So that is also important, means we have to go through all the reactions properly. We have to memorize the reactions, reaction conditions, the products and everything. Then only it will become easy to get the answer during your exam, because we don't have enough time, we don't have more time to solve the questions by writing the entire reactions. So we have to memorize each of the products in between the reactions as well, because we have less time for the exam. So prepare well for your exam by using all the organic, when you are covering the organic chapters, go through the equation several times, go through the reaction mechanism several times, because the questions are asking in between as well. So all the very best for your exam. So now I am ending up here. Thank you.